This is question number 10 out of section 4.4. It was requested by students, so let's take a look at working through this. The question states we have a survey team which is trying to estimate the height of a mountain above a level plain. So the first thing we do is draw a sketch. We've got a mountain, we've got a level plain. We want the height. Let's go here. Change it to red. Get some other colors in here. So we want the height of this mountain. Go down to the center point with the right angle. So this is what we're searching for. From one point on the plane, they, the survey team, observed that the angle of elevation to the top of the mountain is 32 degrees. So somewhere, we'll say here, we've got our happy little survey team, and they look here to here. They find that this angle is 32 degrees. From a point 1,000 feet closer to the mountain, so they walk, maybe to here, and this distance here is 1,000 feet. And when they look up again, this time they see that that is 35 degrees. So this gives us two different triangles. Both have the same height, so that's how we're going to use it. The thing is, we don't know the distance from the second point to the mountain or to the center of the mountain, which really what we would need to know. So we'll just call that x. We're going to see that we're going to be able to figure all this out. So this gives us two different triangles. We've got this one triangle, the 32-degree angle. We know it's the height is h, and the length of the base is going to be 1,000 feet plus x, because it goes all the way from the survey team to the center of the mountain. The other triangle, again, these are not really drawn to scale. I can't tell the difference between 32 and 35, or I can't draw the difference very well. This 35-degree triangle still has a height of h, but the base is only from that point to the center of the mountain, which is just x. And so what we notice is, using trigonometry, what we have is we've got a statement for the base or the adjacent side. We've got a variable for the opposite side. So if we use opposite over adjacent, since those are the sides we know, we don't have any information about the hypotenuse, probably couldn't get that anyway. What that tells us is we should use the tangent of the angle in degrees. Usually when we use theta, we're talking in radians, but I'll emphasize that we're using degrees, and we're going to make sure that our calculator is set up in degrees when we do this. So the statement we get for the 32-degree angle is that the tangent of 32 degrees is equal to opposite, which is h, over the hypotenuse, not opposite over adjacent, which is 1,000 plus x. And then the 35-degree angle, we have tangent 35 degrees, it's going to be equal to opposite, h, over adjacent, which is just x. We've got two equations and two unknowns. So a good way to do this is using substitution. We can solve one of these for h, or both of them for h, and then substitute. I think that's the way I'll go. And so this one, we multiply both sides by 1,000 plus x, so that cancels. 1,000 plus x. This tangent one, 35, we're going to multiply both sides by x. Those will cancel. And so now we've got that h equals 1,000 plus x, tangent of 32 degrees. And then we have x, tangent of 35 degrees equals h. h is equal to h, so we can set these two statements equal to each other. And we get 1000 plus x times the tangent of 32 degrees is equal to x times the tangent of 35 degrees. Now, a couple steps. We're going to have to solve for x. That's not going to be our answer, right? Because we're looking for h, the height of the mountain, not the distance to the mountain, or to the center of the mountain was what it really would be. So we're going to solve for x. Let's go ahead and distribute on the left-hand side. So we'll have 1000 tangent of 32 degrees plus x. Actually, I think we could do that. I'm going to back up a little bit. I think I see a simpler way. What if we divide both sides by the tangent of 32 degrees? So this is going to cancel with that because there's multiplication here. So now we've got 1000 plus x equals x and 35 degrees over 32 degrees. We can subtract x from both sides. So then we get 1000 equals x and 35 degrees over tan of 32 degrees minus x. Scroll up a little bit. We can factor in x out. So this gives us that x times tan of 35 degrees over tan of 32 degrees minus 1. That's right, there's always this coefficient of 1 in front. So we factor the x to the front, and we've got this. That's equal to 1000. Now what I'm going to do is I'm going to, before I calculate this statement with the tangents, the ratio of the tangents, I'm going to divide it over, divide both sides by that. And I'm going to do the same thing here. I won't rewrite it, but this will cancel with that, right? Because they're the same thing. So I'm going to get x equals this statement here. I'm going to do this calculation on my calculator so I don't get any rounding errors in between. First thing I need to notice is that I am in radian mode. That's in the upper left-hand corner here on my calculator. So I'm going to go first down to settings. Notice angle measures in radians. I can come and change it to degrees. And notice in the upper left corner it now says degrees. My menu, go back to calculations. And I'm going to enter this statement just as it is. So it's 1000 divided by, parentheses, tangent of 35 degrees, parentheses, divided by the tangent of 32 degrees, parentheses, arrow out, subtract 1, put a parentheses just for good measure, and then we'll execute that. So what we've got is that x equals 8294.19. That'll be enough decimal places. What we need to do now is take one of those original solutions for x, for h. Take this one here as the simplest. So I'll take x times tangent of 35. That's 8294.19. And actually, since I've got it on the calculator, I'm just going to hit multiply key. Now notice it's going to take the answer, so it will use all the decimal places to be very accurate, times the tangent of 35 degrees. Okay, so taking this number, so h is equal to 8294.19. All that going on times the tangent of 35 degrees, and that's coming directly from that point there. And then when we hit execute, we get that h equals 5,807.66 if you want to round it. It never really said what to round it to. But you've got all the decimal places there, and this is the correct answer to this question. Getting a little complicated, but the key is start with drawing a picture. We've got two triangles, we've got two unknowns. We set up two equations, and then we solve those simultaneous equations. Something we did in algebra actually quite a bit. So a mix of algebra and trig. In this case, maybe the algebra part was more complicated than the trig part, but we needed to know both to solve these types of problems.